Hey guys, we're back to talk about how to solve rational equations in this video. So our last video we started a new unit on rational expressions. That would be fractions that involve variables. And today we're going to switch gears just a little bit and talk about equations. So where you have two sides that must balance and what steps you must take to solve for whatever your variable must equal, if anything, in these types of equations. What you'll see is that the steps to do or to solve this type of problem are going to be somewhat similar to what you did in our previous video on simplifying. So we still are going to factor anything possible. We're still going to look for excluded values. That's where we're going to start. So for this problem, for example, we would start by looking, can we factor anything, any numerator, any denominator? And it turns out in this case, we can, right? The numerator here of 1, denominator of x squared, numerator of 1, denominator of 256. There's nothing that we can break down any further, it turns out, by factoring, so we can skip step 1 in this case. Step 2, we look for excluded values. Remember from our previous video that we can never divide by a 0. Now, I already know that 256 is not equal to 0. I don't need to worry about that, but I do need to worry about when a variable shows up in my denominator. That means this denominator here, x squared, cannot equal 0. So what number would x be for this to turn into 0? You could square root both sides, add a plus minus if you want to. The point is, pretty clearly, x itself cannot be 0, because if I plug 0 into x, 0 squared is 0, and I can't divide by 0. It's an excluded value in this case. So that's what we're going to have to keep in mind. We're going to come back to that later on and use that to double check our work. Step 3, we're going to want to multiply by what's called the least common denominator. So what I want you to do here is take a look at our denominators. Notice that there are two different types, right? One is an x squared, one is a 256. Since we have two types of denominators, we're going to multiply both to our numerators. I'm going to multiply this by x squared and 256, as well as not only on the right side, but also the left side. And the reason I'm doing this is that you should see I can immediately cancel some things out, right? On the left side, I have x squared in the bottom and the top now. On the right side, I have a 256 on the bottom and the top of this new numerator. Okay. Now, why is that helpful? Well, if I look at what's left over, 1 times anything stays the same, and 1 times anything, again, stays the same. And now I'm in a position where I can easily solve this using the root method. At least for this problem, you can see that you can square root both sides. Plus and minus symbol will appear as you are simplifying. And we get two solutions just like we should, right? That makes sense. And in this case, the two solutions are, if you use a calculator to solve that, plus and minus 16. Okay. Two solutions to this problem. Now, before you stop, you do need to double check all of your problems for extra or extraneous solutions. Sometimes this happens where you think you got a solution and it turns out it's not actually a real solution. Okay. Now in this case, we would do that by checking, is this excluded value the same as one of our numbers down here? And it's not, which is good. That means these are real solutions. We're good to go. Okay. But in other problems, it's going to actually happen that these two numbers might overlap, and that means that we have an extra solution caused by our problem, and that it doesn't really count as a solution at all. So these would be the steps though. Factor if possible, find excluded values, multiply by the least common denominator. So how many types of denominators do you have? Multiply those to the top in order to cancel, and work with what's left over. Okay, solve what's left over, double check your problem at the end. Let's do a couple more examples. So one that I'll take a look at here, actually will have an extraneous solution. Okay, so step 1, can I factor anything? Yes. immediately I can see that I have a difference of perfect squares. Everything else can't be factored, but I'm going to rewrite this problem. You can use the box method, your perfect square factoring pattern. Either way, you should end up with two parentheses that you break down by factoring. X times x is x squared. Positive times negative 2 is negative 4, and 2 minus 2 cancels out any middle term that you would have. Remember, when you're factoring, you should always be able to multiply back out your problem to give you what you started with, and that would be the case here. Okay, this is our factoring pattern. Something plus something times something minus something. Square root the right and left terms. You should be able to find that. We've done this many times. Remember, factoring is very important in this unit, so make it a routine. So that is our step 1. We factored everything. Step 2, look for excluded values. So remember, in this case, x plus 2 cannot equal 0, and x minus 2 also cannot equal 0. Now you don't need to write this out more than once. Okay, so just because it shows up more than once, if you tell me that x cannot be negative 2 one time, I know it can't be negative 2 more than once. Same thing here. If you tell me that x cannot be equal to positive 2, then I already know that for all of my parentheses. 2 excluded values in this case. Okay. Now let's go ahead and start looking for our least common denominator. So, good question to ask. How many types of denominators do we have? Now we have 3 total denominators, right? A left side, middle, and a right side of our equation denominator. But the types of denominators, and maybe this is easier if I write parentheses here. How many parenthesis types do we have? How many types of parentheses? We really only have 2, right? X plus 2 and x minus 2. That's our LCD, our least common denominator. X plus 2 times x minus 2. Okay, so here we would multiply that to each one of our numerators in order to cancel some things out. Okay, multiply by the LCD to each of our numerators. X plus 2 will cancel on the left expression. X minus 2 will cancel for the right expression. And both parentheses will cancel for this right side of the equation expression. So notice, what happens every time we multiply by the LCD is that all of our denominators cancel out. It makes our problem much easier to solve, because now all we have to do is work with what's left over. We have 1 times x minus 2, which is just x minus 2. 1 times x plus 2, which is x plus 2. And all we have left over here is a 4. Everything else canceled out. Okay. Simplify, solve, combine some like terms. In this case, we should see that we have a negative 2 and a positive 2 will both cancel. We have a 1x and another 1x we can add together here. 1 plus 1 is 2x equals 4. And lastly, divide by 2 to both sides, and it seems as if we have our answer. X equals 4 over 2 is 2. But in this case, we see why it's so important to double check for extraneous solutions, because it turns out, if we remember from earlier, we said that x cannot be positive 2. So what does this mean? It means that there's actually no solution to our problem. There's no solution because what would have been a solution is actually extraneous. It's extra. It doesn't count. Okay? It's actually an excluded value that we saw earlier. That prevents it from being a solution. There is actually no value for x that solves this problem, which can happen in math sometimes. Sometimes some things just can't equal out, like 3 cannot equal 4, for example. Okay? Nothing you can do about it. Same thing here. There is no value for x that would satisfy this or balance this equation, because what we thought might be a solution is actually extraneous. How do we know that? That was an extraneous or excluded value that we saw earlier. Okay. One more example that we'll do. I'll put that over here maybe. So for this problem, once again, try to follow your steps. Factor if possible. First, can we factor anything here? No. So we can skip that step. Step 2, find excluded values. So we have two denominators that have variables. We don't need to worry about this last one. Remember, we already know that 8 is not equal to 0. Don't have to worry about any division of 0 over here. In these cases, it could turn out that we divide by 0 if x is a certain number. We want to make sure that doesn't happen. In this case, we see that x itself cannot equal 0. Right? If I plug a 0 in there, that's a big problem. Right? That's an excluded value. And in this case, we see x minus 12 cannot equal 0. If we add 12 to both sides, we see that that means x cannot be positive 12. Okay, because 12 minus 12 would be 0. X itself cannot be 12. So two excluded values there, 0 and 12. Let's keep those in mind for towards the end of our problem, and make sure that we are not ending up with an extraneous solution. Okay. So what we do next is to try to, again, multiply by the least common denominator. In this case, we have 3 types of denominators, notice, right? We have 3 denominators and none of them overlap. So we have to multiply by 3 things here. We have to multiply by 8, x, and x minus 12. That's our LCD. Our LCD is 8 times x minus 12. Okay. Have to multiply that to each of our numerators in order to cancel out all of our denominators. Try to make things a bit more simple. Right? So for example, what cancels out on the left expression would be x and x. What cancels out in the middle would be x minus 12 and x minus 12. What cancels out on the right? 8 and 8. Everything else can be simplified, right? 1 times anything stays the same. 1 times anything, sorry, that should be an 8 there as well. 1 times anything stays the same. We're adding here. Equals 1 times anything, once again, stays the same. Okay, so in this case, we didn't really have to multiply by much. We do still need to do distribution here, right? 8 times x is 8x. Let's simplify this a bit. Minus 96 plus 8x. There was an x here as well, actually. My bad. There was an x times x minus 12. I completely missed that. We only canceled out the 8. We did not cancel out that x in front of our parentheses. So be careful as you're doing this. Don't leave any missing terms out. It's x squared minus 12x. Okay. Combine some like terms here. 8x plus 8x is 16x minus 96 equals x squared minus 12x. Now in this case, what you'll notice is that we can't do what we did before, right? In our last example, we were able to put variables on one side and leave numbers on the other side, right? 4 was on the right side of our equation, 2x was on the left side, okay? And then we just solved to find what x would be by division. In this case, however, we notice that we have an x squared. And because we have x squared, that means we're actually going to need to solve by factoring. Okay? We're going to need to move everything from one side of our equation to the other by opposite operations. So let's subtract by 16x and add by 96. Subtract by 16x to a like term, add by 96. We're setting everything equal to 0. Okay, in order to solve by factoring, this is something that we did earlier on in this semester. So it should look somewhat familiar. And what you can do here is the box method to factor and solve. So set up your little box. Think about what times what equals x squared. Okay, clearly that would be x times x would equal x squared. So that will be part of our parentheses that we're breaking these down into equaling. Think about what times what equals positive 96, but also adds to give negative 28. So if you think about what times what is a positive, but adds to give a negative, clearly we have to be multiplying by negative numbers. A negative times a negative is a positive, but if we combine negatives, right, we'll get negative 28 somehow, and that would be by multiplying negative 4 times negative 24. You could try to look for a list of possible things, right? Negative 1 times negative 96, negative 2 times negative 48, so on and so forth. It turns out negative 24 times negative 4 will be positive 96, and negative 24x combined with negative 4x will be negative 28x. Remember, you should always be able to multiply your parentheses back out to equal your original expression, and in this case that would work. So our solutions, it turns out, should have two of them here, it looks like. Set x minus 4 equal to 0, x minus 24 equal to 0. Okay, it makes sense that we would have two solutions, right? And add to both sides these numbers. We find x equals 4 and 24. Now, the only reason that I can go ahead and circle that is, once again, if I check those against my excluded values, was 12 one of my proposed solutions? No. Was 0 one of my proposed solutions? No. Now, if I had x cannot equal 4 up here, then this would be extraneous and we would only have one real solution. Okay? This would be non-real, or extra. But that was not an excluded value, so don't have to worry about it. Same thing, if x could not equal 24, let's say that was x minus 24 on the denominator there, then x could not be 24, it would be an excluded value, and this would be extraneous. Again, though, that did not happen, so we do actually end up with two solutions, not just one. So that is how you would solve rational equations. Again, always follow these steps as you're trying to do that. So factor if you can, sometimes you can't, that's okay, skip that step. Find excluded values by looking at the variables in your denominator, seeing what are they not allowed to equal. Step 3, multiply by the least common denominator to all of your numerators in order to cancel some things out. That way you can go ahead and solve like normal, either by factoring, as we did here, or in our previous example where we just were able to set variables to one side of our equation and numbers to the other. And once you do solve, always, always, always check for extraneous solutions. Okay? You can never have a solution that is also an excluded value. So be careful with that. That does wrap up our video on solving rational equations. The last video that we'll make, and the last new material for this semester actually, will come next week when we talk about what else we can use excluded values for in relation to graphs. So I will look to see you then. We're almost done with the semester. Finish strong, and I'll be here to support you however I can.